Problem 16 in our review. A card is drawn from a standard deck of 52 playing cards. Find the probability that the card is an ace or a king. Probability of ace or a king. Now we've moved into a different probability rule. This is the addition rule, or sometimes the or rule, because this is one complex event, one event that has, instead of successive events, it's just asking that we draw one card. And what is the probability that that card's an ace or a king? So recall that the probability of A or B occurring is the probability that A occurs plus the probability that B occurs minus the probability that they both occur together. In other words, and you'll see when we work some of these problems, that in some cases there's some overlap. And then when that happens, you count things twice. So you have to subtract it back out once to balance it out. You'll see that soon enough. So this question asks, what's the probability of an ace or a king? We know that that is, let's see, ace or king. That is, according to our rule here, the probability of being an ace plus the probability of being a king minus the probability of being an ace and a king. The probability of choosing an ace, there are 4 aces in a deck of cards. There are 52 cards. The probability of drawing a king, there are 4 kings in a deck. There are 52 cards. We're not reducing the size of the deck because this is not successive events. This is just one event. Now this last part, the probability of ace and king, you ask yourself, is there any card in a deck that's both an ace and a king at the same time? And the answer to that is no, there's not. So that becomes 0 and doesn't really play into this problem at all because these are called mutually exclusive events. They cannot happen at the same time. You cannot beat both an ace and a king at the same time. We get 8 over 52, which reduces to, what's that? 4 over 26, sorry, 2 over 13. There we go. So the probability of drawing one card in an ace or a king is 2 over 13.